Hey, bioanatomy students, welcome back to another session of anatomy. We're going to try and see if we can finish up most of the notes today. And we left off with this slide on the last episode, and that's where I want to pick up today because it kind of all goes together. And we're going to go back and forth between some notes and this picture right here. So if you flip to the back of your note packet, this diagram's on there. So we're going to fill in this top little part. This is where this is where muscle contraction starts. It's a process. And this is going to be an essay on Tuesday's test. So, and you can do it just like I have it here. You don't have to write an essay. You can just write this chart. So nerve impulse leads the brain. That's where we start, okay? So we talked a little bit yesterday about how a motor unit is where a nerve comes in and connects to the muscle. So you're talking about this right in here. That's where everything starts. If you don't get that that nerve impulse down to that muscle is not going to fire, not going to do anything. And to kind of wrap up what I started yesterday, motor units may stimulate 5 fibers, or they may stimulate as many as hundreds at a time. So, and the fewer fibers, this makes sense. The fewer the fibers, like your fingers, I talked about that yesterday, the more precise the movement, whereas your back has hundreds of them hooked together, all right? Hang on, let me pause this for a second, close my door so no one interrupts us. Okay, so that's how we control things is we talked a little bit about this the other day too. When a nerve impulse reaches the muscle, your muscle is going to fire full force or not at all. So the only way we can control that is by only stimulating 5 fibers or 50 fibers or 100 fibers, and that's what controls the strength of a contraction. All right. So that area of contact. So what we're going to do is we're going to switch over from an electrical type of system to a chemical type of system. So when that nerve hits that muscle, whether it's 5 fibers or 100 of them, we're going to release a chemical, and this is really important. It's called acetylcholine. So let's go back to our diagram, okay, and write that in. So the nerve impulse leaves the brain. The impulse releases this chemical called acetylcholine. That is the trigger. So if acetylcholine is present in your muscle is going to contract. That's kind of how it works, okay? And the only way, acetylcholine is in these little vesicles, these little sacs. They do not want to leave those sacs. They're attracted to that sac. They stay in that sac. We have to force them out, and we do that by an electrical impulse. And that's just like opening a floodgate. So acetylcholine spreads throughout the neuromuscular junction, that little gap where the nerve and the muscle meets. It just kind of oozes through there, and it's going to start a muscle contraction into motion, okay? So a muscle contraction, what that's called is the sliding filament hypothesis. That's this diagram right here, okay? So that's where it all starts. Someone who's paralyzed, the nerve impulse just never gets to this destination. Acetylcholine doesn't get released, the muscle doesn't contract, okay? It's not like all the parts are not there in a paralyzed person, because they are. That's why we're trying to, they're doing research to try to find a way around that. It just doesn't get to its destination. So acetylcholine will not leave these little vesicles unless a nerve impulse makes them go out of there, okay? And then acetylcholine is going to contact something called a sarcolemma. Don't get confused by that. A sarcolemma is just the plasma membrane of a muscle cell, or cells, plural. And that's what's going to set all this stuff into motion down here, okay? So let's go back to our notes. Okay, so acetylcholine contacts the sarcolemma. There's the rest of that statement, the plasma membrane of a muscle cell. And then acetylcholine triggers all kinds of things, sets 2 things into motion at the same time. So this is where it gets a little bit crazy. So kind of stay with me a little bit and see if this will make sense. I just want to kind of get through this today, and then we'll wrap up notes tomorrow, and then we'll be done for the trimester. Woohoo! Okay. So here's the deal. Okay. So you open up these floodgates, this acetylcholine is released. Now you're going to notice that my diagram goes 2 different directions now. Okay. Simultaneously, 2 things happen. when acetylcholine gets released, calcium gets released from their little holding vessels. So they're in little sacs as well. They don't want to leave either. So just like a nerve impulse forces acetylcholine out, acetylcholine forces calcium out. Okay. And at the same time, little Bio 1 review, we're going to hydrolyze ATP or break ATP apart. If you guys remember, energy is never created nor is it destroyed. It has to go somewhere. So we have stored up all this energy in ATP from digestion of food and throughout the day. And this is where we're going to use it. So ATP gets broken apart by acetylcholine. So acetylcholine does two things, very important. Releases calcium and breaks apart ATP. Okay. So that's where we're at in notes. Okay. So far, so good, right? So acetylcholine triggers the release of calcium and hydrolyzes ATP. So there's two things that happen at the same time. Okay. Now, this is where the chemistry comes into play. So let's kind of work our way through this. So I'm going to keep going back to this. Nerve impulse comes, releases acetylcholine. It gets spread throughout the muscle. Acetylcholine releases calcium and also breaks down ATP. Okay, hopefully that makes sense so far. Okay, now let's just look at the left side. Okay, so what happens to the calcium? You can see from the diagram that calcium is going to combine, it gets released from the sacs of the sarcoplasmic reticulum, which is this an organelle in the muscle, and it's going to combine with another chemical called troponin. All right, so now we have something called calcium-bound troponin. So let's go back, and that's what this little letter C here says. Calcium will spread to the sarcoplasmic reticulum, which is the sarcoplasm, which is the cytoplasm of the muscle. It binds with troponin. And now we're going to turn on actin. It's like actin sitting there, that little thin myofilament we talked about the other day. I think that was the question of the day, too, for bell ringer. It's going to basically almost like adding glue to it. It's going to turn it on. Okay? So calcium-bound troponin allows myosin and actin to hook. I talked in the last video about how a muscle is contracted if actin and myosin are connected. If they're not connected, a muscle relaxes. The only way myosin and actin will connect with one another is if this chemical called calcium-bound troponin is present. Okay? So calcium-bound troponin allows those cross bridges to form. So write that in. So calcium combines with troponin, turning on actin. These cross bridges form, which is literally myosin plus actin. Now, it doesn't do us any good if I have these hooked up if I don't have any energy to move them, right? This is where that part 2 comes in, right? So I said that acetylcholine not only releases calcium, it also breaks apart ATP. So here's where ATP comes in, part B. All that energy gets released when we break apart ATP, and it comes over and it rotates this myosin and actin and makes the muscle go shortens, and your muscle contracts, and you move your arms and legs and whatever you're moving. Okay, it works like a ratchet wrench. I don't know if any of you have ever used a ratchet wrench, but basically it moves kind of like this, kind of catches and moves, and the muscle then shortens. Okay, and that's pretty much how this muscle contraction works. Okay, so going back to the diagram, you see all that. My calcium-bound troponin hooks up myosin actin. The energy comes over, the cross bridges rotate, and we shorten the muscle and make it contract. Okay, so that's pretty much how a muscle contracts. Short version. And make sure you look this diagram over. This is a big 10-point short answer / essay, or you want to call it on the test. And you just have to put the main points and get all these parts in here to get the 10 points. All right. So hopefully that makes sense a little bit. I will put the notes online tomorrow, and you can watch this video, which goes through it as well. But it's pretty much the same thing I just explained to you. Same way with this video. There's little video clips that will help you. And then kind of wrap it up. And once that happens, once we release calcium, and once we release acetylcholine and all this gets set in motion, that muscle is going to fire full force or not at all. Okay, And the way we can control how much of that muscle we use is by turning on 5 fibers, 50 fibers, 100 fibers, depending on if I'm picking up a 50-pound weight or I'm picking up a piece of paper, right? So look that over. I know that's a lot that I gave you today. Went back and forth between the diagram and the notes. Hopefully that makes sense. I'll kind of review that a little bit at the beginning of notes tomorrow, and then we'll wrap things up. And I'm going to show you what kind of things can affect this, how we reverse this, it causing muscle to contract, and we'll talk a little bit about that. Got about 2 slides left. So that's pretty much the trimester laid out. We're going to finish up notes tomorrow. Got a little short little web quest thing you'll do for your e-learning Friday. Monday we'll have a little quick Kahoot game, and then Tuesday we'll take our Google form test like we've been doing. All right, and then we'll be done with the first trimester. So I'm hoping you're having a great day. Again, as always, if you got questions, shoot me an email, which you guys are pretty good at doing, and have a great day. We'll see you later. Bye.